Hello my dear students, this is chapter 13 sound, but in the previous part you have learned about the sound and you have learned about this musical instrument, how they are creating the sound, the variety of sound get generated through this all the type of various instruments, and what is sound, how it is created with the examples you have seen in the previous part, as well as the instrument and their vibrating part which is producing the sound also learned in the previous part. This type of instruments are there by which the different type of sound can be produced, and in human being how the sound is produced with the help of the larynx. So here this is the diagram of the larynx, it is shown in the previous part also. So now today you are going to learn sound requires a medium to propagate. Now see here, the sound travels through solid, liquid and gases. So here it is important how the sound travels. So we know that sound travels through solids, liquids as well as gases. If you see these two children are there, by using a cup of phone, means a telephone, it is made by using a small cup, plastic cups, and which are tied at the center of the bottom with a long thread, and this activity is given in a book. So when the two persons are standing far from each other and when they place a small cup on their ear, so whatever the another person is saying, that can be heard here. So but there is a one proper way, that thread should be straight, there should be no any barrier, or it should not get touched to any other substance. Now see here, so from this activity you will come to know the sound can travel through solid medium. So here a thread is the solid medium, and here in the picture you can see aquatic animal fish is there in the sea. So this whale can listen the reflected sound in water to locate its prey. So here through the liquid also sound can be propagated, sound can be traveled. And if you see the person is speaking, so whenever teachers speak in the class, the student can listen. So this teacher's sound can be travel through the gases, means air. So we are able to listen to sounds because sounds travels in air. Air means a mixture of gases. So all these are the mediums through which the sound can travel: solid, liquid and gases. This is the instrument by which we can prove sound cannot travel in the vacuum. So here is the vacuum, here is no air inside the instrument, so sound cannot travel in the vacuum. By this experiment it can be cleared. Now here, how we hear sound through our ears. Now see here, this is the diagram of our ear. So inner part of the ear also shown here: outer ear, eardrum, ear canal, middle ear and then inner ear, and this is the Eustachian tube. Now see here, this is the outer part of the ear where the sound strike on this outer part, then it goes inside the inner part, ear canal, and through the ear canal it strike on this eardrum. So eardrum starts vibrating, and because of the vibration the sound can be reached up to the brain. Now see here, the sound enters ear through the ear canal. So this one is the ear canal. So through the ear canal the sound can enter into the ear canal, and when this sound will enter into the ear canal, it makes the eardrum to vibrate. So this eardrum starts vibrating. So when it starts vibrating, eardrum sends the vibration to the inner ear. This part is the inner ear, this part, and then inner ear, this vibration gets sent into the inner ear, and from there the signal goes to the brain, and then we hear the sound. Now what is the amplitude, time period, frequency of a vibration? So amplitude, then time period, and then frequency of vibration. So this is the diagram of the simple pendulum. So this is the pendulum, this is this circular thing is nothing but it is a bob, this one is the thread or the chain. Now the vibration is, what is the vibration? As I told before, vibration is to and fro motion of the object. Now this to and fro or back and forth motion, to and fro, back and forth motion, to and fro motion is nothing but it is called as vibration, and it is also called as oscillatory motion. So oscillatory motion is also to and fro motion or back and forth motion. So vibration is also called as oscillatory motion. Now see at the maximum displacement, what is the amplitude now? This first word is the amplitude. So before the amplitude you have understood what is the vibration. It is nothing but the to and fro movement of an object or oscillatory motion of an object. Now what is the amplitude? So the amplitude is nothing but it is a maximum displacement of an oscillating body. So here the pendulum, this pendulum is the oscillating body. It is moving to and fro, it is moving back and forth. So this is the oscillating body. So maximum distance of an oscillating body from its center position is called as amplitude, means OB or OA. Now see here, this is the center position of the simple pendulum, and when this bob move from this center position to this side, to the right hand side, so whatever the maximum distance is covered by this bob means OB. This is the maximum distance covered by this simple pendulum. So this OB is the amplitude. When the bob moves from center to the left hand side, so whatever the maximum distance it can cover, that is the amplitude, means OA is the amplitude of the simple pendulum. Now motion of the pendulum from one extreme position to another extreme position is position and back is called as oscillation. Now see here, what is the oscillation? The next word is the oscillation. So what is oscillation? The motion of the pendulum from one extreme position to another extreme position and back is called as oscillation. Means now suppose this is one extreme position A. So this pendulum will move, the motion of the pendulum from one extreme, this is one extreme position and this B is another extreme position. So from A to B it will go, and then from B to A back. So that will be the oscillation. That will be calculated as a one oscillation. So when this simple pendulum move from this A position to B and B to back A, then it can complete one oscillation. Now whatever the time is taken to complete the one oscillation is called as time period, and the number of oscillations per second, means in 1 second how much oscillations are get completed, those the number of oscillations are called as nothing but frequency. Means the number of oscillation completed in 1 second is called as frequency, and we know that the unit of the frequency is the hertz, which is shown in this slide. So hertz, it can be shown as a capital H, small z, and it can be written as HERTZ, hertz. It is the unit of frequency. Loudness and pitch of the sound. The loudness, what is the loudness and the pitch? So loudness of a sound, how it is depending upon, so this loudness of sound depends upon amplitude of the vibration. So you know that what is the amplitude. So in the previous slide I explained what is the amplitude. So on the amplitude of the vibration or amplitude of the oscillatory motion, this loudness of the sound is depending upon. Now if the amplitude is less, the sound is feeble, and if the amplitude is more, the sound is loud, depending upon the sound. Sound is less, then sound is if the amplitude is less and the sound is then feeble, then if amplitude is more, then sound is loud. And we know the unit of the loudness is called as decibel, which can be shown as small d and capital B. Decibel is the unit of the loudness. So loud sound can be measured in the decibel. And pitch is the sound depends upon the frequency of the vibration. So on the frequency of the vibration, the sound depends, and that is called as pitch, and on the amplitude of the vibration, the sound depends, that is called as loudness. If the frequency is less, the sound has a low pitch, and the sound of a drum, sound of an adult person, these are the examples of the low pitch. If the frequency is high or more, then the sound has high pitch. Example, the sound of whistle, a sound of baby, small baby when starts crying. We put fingers in our ears. When someone whistles loudly, then also we keep finger in our ear. So that is high pitch sound. So that's because the frequency of the sound is more, so it can be a high pitch sound.